Hello, today I want to continue our discussion of different kind of loop patterns. I want to add a little more about search loops and then talk about optimization loops, where you're trying to find like the best of something. Last time we discussed enumeration loops, which is really just giving a name to something we've already done. And hopefully you saw in the last assignment, working like with the sound files, for example, you were doing sort of enumeration loops, right? You were scaling every sound sample, and that still does something useful. And then we talked about accumulation loops, which again is something we've been working on informally already, where we're building up an answer, the sum of the values in an array, breaking apart a string and building it back up again to make a reverse string. Things like that are all accumulation loops. And then there's search loops, where we're trying to find something in a collection. And again, there's sort of a variety of variations on this theme. You can, for example, return the item if you find it. You could return the location of the item, or you could return true or false. And they all have, the same basic idea. You have a loop looking at each one, and you have an if statement to see if you found it, but then you need to somehow decide what to return. All right, so there's one thing that needs to come up, and it's going to start running into it. And to be honest, it's a huge source of errors in code. And so I want you to be aware of this issue and certainly think of it as you're writing your own code. And basically, that is when you're comparing two objects, and like, for example, two strings, the equal operator, which we have used to compare values for primitive types, basically just means that it's the same reference. In other words, the same object. It doesn't mean that it's like an object holding the same kind of data. So there's a method of objects called the dot equals method, and that allows you to compare sort of the internal data. Are these two strings, do they have the same characters in them? Do these two other objects have the same kind of data? So I want to show you how that works a little bit. So I'm going to write a method that compares, that searches for a string name and a bunch of names. Really, the name, it could be any kind of string. It doesn't have to be a name, but that's the sort of motivation here. So public static, and I'm going to return true or false. So Boolean return type, and call this search for name. And coming into this thing, I'm going to have a string array of names, and then the string that I'm actually looking for, name. And I need a little space here. Somehow I don't have quite as much space as I wanted to write stuff, but all right, we'll just work with that. So I'm going to do a standard, and to be honest, this for loop shows up so many times, and it's okay to make it exactly the same every time. You don't have to like reinvent the wheel, give it some weird special variable name. Just do this thing that is well tested, and that way you don't make any mistakes, hopefully. So let's say, okay, so we're going to look at each item here, and I'm going to say if the name we're currently looking at, names at index, equals name, so are they the same? I'm going to return true. And if I have gone through the entire loop and not found this thing, I'm going to return false. Now this is not quite right, and I want to show you why. And I'm also sorry for my camera bouncing around. I'm kind of balancing this on my lap and I type, and so I know it gets a little jerky. But so I'm going to make an array of names in main to test this. And I guess I'll have David, and let's pick on a couple of our TAs here. All right, so I've initialized names with 3 strings, and I want to search for name, and I'm just going to print out the true or false. Again, it's not, not a very complete test, but let's just kind of get moving here as a quick example. So I'm going to print out the result of calling search for name, passing in names, and I'm going to search for David. Well, that wasn't going to work. So if it finds David, it's going to print true, and otherwise it's going to print false. So here's the thing. It seems to have worked. I was just talking about how we shouldn't use equal equal to compare objects. Strings are objects. And this is actually one of these things that's a little hard to demonstrate because there's some subtleties here. So let me make I am going to make a new string here. So here I'm calling, let's see, am I missing? Yeah, one of those. Before I gave it a string literal, right? David. And Java interprets that as a string and makes a string object out of it. And if I make a new string, it also says, what string do you want? Well, I want to make it out of David here. But let's just run this and just see what's going on first of all. So first of all, it says false. And why is that? Well, that is because we are comparing this object with this object, and they are different objects. In other words, when you say, make me a new string, what does it do? Well, it creates a string object on the heap, and the result of this operation here is that it returns that reference. This reference was passed to here and assigned to name, and that reference in here was compared to the reference coming out of this one here. Now, the reason it worked before when I had just David was that Java is doing something when it sees this string literal and says, that seems to be the same one as this one. Let's make those the same object. So actually there was only one David string on the heap with this case here, and they both have the same reference. And so I passed that reference to here, compared it to here, and it was true that it's the same object. But when I did a new string here, I forced this to be a completely different David, and we were comparing the references here, and it never found one that was the same reference since these are different objects here, and it returned false, right? So I'm going to run that again, return false. When you are comparing two objects, you need to use the dot equals, and that basically says whether the characters, in other words, there's some code written in the string class that says, how do I compare two things? Well, I want to look at the characters and see if they're the same. So there's some loop that goes through them each and says, hey, are they the same? Are they the same? Same. And when they're not the same, it returns false. And when they're all the same, it's true. So if I run this now, it says true, even though this is a different object than this one. Their characters are the same, and the property of the string class is that dot equals checks for the same values stored inside it. This is something people have to write. Like when we write our own classes, we are going to write a dot equals and say, how do I compare two of these two objects? How do I decide if they have the same values? And you're just looking at stuff stored in there and figuring out some way to say that they're the same. But if it's equal equals, you're just comparing the reference. If this is a little confusing, I would urge you to go back and look at lecture 8C, which talks about stack and heap. And we'll be pushing this issue quite a bit during the semester. And while this is just the beginning of it, it's okay to feel a little uncertain. I want you to kind of force yourself to kind of review that and hopefully make some sense out of it, ask questions and so on. So remember, variables of object type, like a string, holds not the object itself, but a reference of a location of where that object is, right? It's a single number. Okay. So anyway, here's some code, right? We have the search target, the key or target. We have a collection of items to search. We loop over each one of those things in the collection, and we check with dot equals whether they're the same value. And if we find it, we return true right away and exit the loop and the method. And if we get through the entire loop without returning, that means we hit this case here, return false that we didn't find it, right? So that's your basic search loop. But when you're doing some stuff with objects, again, this dot equals is important. I see a ton of code in assignments where people just use equal equals and fail certain tests, and that's because Java is not going to warn you that you're doing the wrong thing. It thinks, oh, this person wants to see if those two objects are exactly the same object, right? Not that their values are the same. And so it's up to you to remember that dot equals is the way to compare two objects. Now, what if we wanted to search for words that started with D? Let's D for David, hopefully, right? Public static. I'm going to return the word if I find it, string, search for starting with D. And I need a collection of stuff to look at here, so I'm going to copy that. I don't have a target. The target is just the first word that starts with capital D. So I don't need another parameter here. And I am going to steal this loop because we want to look at each word in this collection of names here. And just to kind of maybe hopefully make it a little more clear, I'm going to pull out a name into a variable. And again, you don't have to do this. I see in the last assignment people are sort of always assigning the return of looking at like a value in an array into a variable before they use it. And you don't have to do that, just where you think it helps clarify the meaning of the code. And so, this is probably not that critical, but I want to make sure you pull out a name, and then I'm going to look at that name for the letter D. So if name.char at 0, so at the 0th location, the first letter, if that is equal to D, the character D, I'm going to try to return that name, right? So the goal of this thing here is you search through the collection of stuff, and then you you pull out the names one at a time, and you look at the first letter of the name, and if it's capital D, you say, I found it, and here's the name. Okay, so that's half the battle. The other part is that what do I return if I did not find a name that starts with D? Well, you could sort of come up again with a special case, like an empty string, to show that. And, that's a decision you have to make. But one option is to return the null keyword. And the null keyword is basically used with object type variables to mean you're not looking at any actual object. In other words, you're storing a null reference, a zero reference, an empty reference. So normally a variable holds a reference to an object that exists in the heap somewhere. And if you wanted to say, I don't know anything about any object, you use this null keyword, right? It means there's nothing there. So null comes up quite a bit. Like if you have an object variable and you haven't you don't have anything to initialize it with yet, you can do some computation first. You can start it off equal to null, and then it hasn't been set properly. So I can just make a variable string stir equals null, and that means I'm not looking at a string object now, right? So this is it's like a special case, right? It's not an empty string. It's not a string that has some value. It's not an object at all. It's just, I'm not yet pointing at anything meaningful. And that's different than like a primitive where, if you start off a primitive equal to 0, that's still a value. I mean, it still means something. In this case, null is like a super special case. I'm not looking at an object at all. And if you try to do something with that, where'd my cursor go? If you try to use that variable that's null, and so this is basically saying null.length, that's an error. It's not going to give you 0. It's because the object doesn't exist, and you can't access a method on the object unless there's an object there. So using this with null is an error, and also calling dot equals, if one of these is null, that's also an error. So you can't test for null using this because it takes two objects to compare themselves. And so first you could, for example, test to see if string is equal to null. So in other words, is the reference in string the same as null, but basically 0? And if that's true, you don't want to do any of these kind of tests on it. I think that's, you'll see this come into play a little bit more, but it's a source of confusion for sure. And I want you to be exposed to it now. So null, we've talked about a little bit, but you can't just use it where you would normally use a full-fledged object of that type. Okay, so those are sort of some special things. Null is actually a great special case to return from something like this because you can, you know, there is no string starting with D, so why return a string object at all? This works as a string type, right? You can use null and assign it to different object types, but you can't actually start accessing values from it. So it does cause problems. All right, optimization loops. We want to search for the most extreme example of something, like the biggest number, or the smallest number. So, it's not always like the biggest, it's just the most extreme, right? The longest of something, the highest count of something, so on. And the basic idea is we're going to look at each of the items in a collection, and we're going to use a variable to store the best value so far. And this is a little different from an accumulation loop where we're using that variable and building up an answer. In this case, we are sort of holding on to the best thing we know so far, right? And so it's a little different. So let's look for one that's like the longest string in an array of strings, and I'm just going to call it longest word, so public static, and we're going to return how long it is, right? So an int. So is this 10 characters long or whatever? Longest word, and again, I take in a collection of words, and the goal is we're going to look at each one of those words and see how long it is, and if it's the best one we've found so far, we're going to remember that. So we need a place to store the longest one we've found so far, and I'm just going to call that longest so far. And we're going to start that off at 0, because before we look at any of them, the longest is 0, basically, right? And now I'm going to loop over each of these words. And again, you think for the number of times I'm going to type this out, I could get it nice and smooth, but still easy to mess it up. And notice here, this bad formatting here, it just wouldn't fit. It's getting kind of tiny. So a little spacing is nice after each one of these semicolons. Spacing around your assignment operator there. And, just try to pay attention to the basics of how we are setting up our code. Okay, so I'm going to look at each word and I say, is this one longer than the one you want to have found so far? And so we check, right? Is this one the words at the index and its length? Oops, this is a string. So this is where, I was about to do, well, first of all, I was about to do length because I was kind of thinking about arrays. But what comes out of words at index? That is a string. And the way you find out the length of a string is you call its length method, right? So you always have to be looking at these little things and thinking like, what kind of thing is this? And that tells you what kind of things you can ask it to do. So if the length is greater than longest so far, in other words, we start off at 0. As soon as we find a word with some length, like 1, is that bigger than longest so far? Yeah, it is. I'm going to set longest so far equal to, I'm just going to steal this here. I probably could have typed it just as fast, really, but okay, longest so far is equal to the word's length, right? So it always has this weird like mirror image thing when you're doing this optimization stuff. You're comparing the thing you're looking at with the best you found so far, and then if it's true that it's better, then you go the other way. You assign to that best so far the thing you were just looking at, right? So just keep that in mind. It's going to feel a little funny because it sort of feels redundant, but you're doing two different things here. Okay, well, what did I just do? Once we've gone through all of the words, we can return the longest so far. Now I'd like to point out something a little different. In search, we are often escaping quickly when we find the thing we're looking for. And we say we're done. We've already found it, so we're going to return early inside the loop. And then we only hit this point when we haven't found it. With an optimization loop, we have to look at all of them, right? We don't have a choice. How do you know something's the longest word? You have to look at each word. as soon as you find something that's kind of long, you don't get a return right away. So we're always looking at every item in this search here to return the longest so far. All right, so we start off with the longest so far is 0, and then we keep checking, and if it's good, in other words, if it's a new better choice, we remember it, and then after checking all the values, we return the best. So that works pretty well. Let's try to use it, I guess. And again, these are not good tests. Again, normally we're asking you to describe what's going on, describe what values are being sent there, and test different cases, right? But longest, what do I call this thing? Longest word. I'm going to pass in names, even though the names are not that different in their lengths. And if I run this, okay, we get 5 because David or Misha are both 5 longer than Josh, right? Now let's try to do the smallest one, and I'm gonna do it down here, I guess. So let's look for the smallest number in an array. So public static int, returning the smallest number. Smallest number, and it takes in an array of values. And I need some place to store the smallest so far. And I'm going to leave that unassigned for a moment. Then we have our loop, or index equals 0, index less than values dot length, index plus plus. And if the one we're looking at right now, values at index, is less than the smallest so far. So we're going the opposite direction here. Then the smallest so far equals that value that we just decided was better. And at the end of this, we return the smallest so far. So we have a bunch of numbers: 10, 5, 3, 1, 1,000. And we want to get that smallest one. So if I put 0 there, that wouldn't work because 0 is going to be less than all those values that I put in, right? So for example, let's make an int array vals equals 10, 1, 5. I don't want to start with the smallest one because then, maybe by chance I'm sort of picking that one out. And I'm going to print out smallest number of vals. And if I run this, I get this 0 because none of them were smaller than 0, right? So I said, is 10 smaller than 0? No. Is 1 smaller than 0? No. Is 5 smaller than 0? No. Return 0. 0 wasn't even one of those possibilities, right? So let me tell you what people do a lot. They just put in some big number. And you run it, and you get 1 that comes out. So that's cool. That's what we're hoping to see. But it's not right, because look. 1, 2, 3, 4, 5. Do I have more there? I don't know. And if I run this, it prints out this number, not one of those, because this is smaller than all of those, and so that's not an appropriate upper bound. So how do we do this in a good way, in a formal way? The sort of correct way to start off an optimization loop, especially when you can't prove something about where it can start off. So for example, longest so far, you're sort of okay starting off at 0 because that's we know there's gonna be some word in there that's not that can't be a negative length word, basically. Here we don't have any of those kind of bounds about what's smallest, and so the correct kind of thing to do typically is to use the first value to initialize the smallest so far, because that's one of the existing numbers. And if it is the smallest one out of all of them, then it keeps that one. But if it's not the smallest, it replaces it. But it's not some fake number that you put in there that gets used when you pick some numbers like this. Now there is this thing called integer. What is it in Java? Max int. Doesn't seem like it likes that. What is max value? That is the biggest number that integer can represent. And so in some ways, none of these other ints can be bigger than that, and maybe that's a reasonable upper bound on this. I'm going to argue that that's not true because at some point you might decide to turn these not into ints but into longs, which can hold more values than integers. In other words, bigger numbers. And you might change these to longs, but you might forget to change this one basically, right? You're not like that. You're not thinking that carefully. You're just doing like maybe even a find replace and replacing int with long. In that case, you just broke this because this is not an upper bound on that long value. And you can't use it long max value here because you're trying to store it in an int. And so you can't sort of preemptively do it. And so anyway, people will like to try to do this integer max value stuff, but it's a false confidence. The proper way to initialize, and sometimes, if it's not an int, if it's some other weird thing, you don't have this kind of built-in biggest possible thing. So instead, we're going to use this values 0. So we pull off the first one, and then if we find one that's better, we use that. But we know it's at least part of the group of existing values that you're trying to test against. The downside of this is that it basically assumes that this thing has at least one value, right? So that can be written into the documentation, or you can check that or something like that. But it does, require some additional complexity there that this thing exists. But the right way to do an optimization loop is to start off with the first value in that collection. And then here, I could technically then go from 1. We've already grabbed the 0 value, so we can start from 1. I don't think it's the worst thing in the world just to make it a standard looking loop. No one's going to complain about that. The performance hit is so super tiny. But this is a better way to do it. So again, you can't just slap a big old number in there. It's not guaranteed to work and probably guaranteed to fail at some point. And so you want to initialize your variable with the first item and not try to pretend to find some number that's really big or hopefully too big. And just be aware of this, these side effects that if you're grabbing the first value, you have to make sure it's there. All right, so what I want you to think about a little bit is how do we initialize these different loop patterns with counting? We basically start where we start to count, or 0, if that's the standard kind of counting. Accumulation, we're starting with some sort of empty case, an empty string that we build up, 0 for a sum kind of thing. Search, you don't really initialize anything because you're just trying to find something. And so you can just return it when you find it. And optimization, we initialize with the first item when possible. In other words, when that makes sense in the context, grab that first value and initialize it. So enumeration, optimization loops are not that hard. You just loop over everything, check, update your best answer, and return it when you're done. If you follow that pattern, you're in great shape. All right, thanks, bye.